Hi, Garfield Chemistry students. Here we are once again. Let's do an example of a problem from your student note problem set. This is problem number 4 and talks about the discovery of oxygen. Joseph Priestley discovered oxygen, but he did an experiment that basically involves this particular reaction here. Now, what we're saying here is with 125 grams of oxygen produced, how many grams of mercury 2 oxide would it take to do that? Now we need molar mass. So we're going to need some molar mass values of the oxygen and also of the mercury 2 oxide, which this is the formula for that. And then we need a balanced equation. So let's do that real quick. O2, remember the best way to do that is you got 2 oxygen atoms. So 2 times 15.99 is what I use. And that turns out to be 31.98. 31.98 mass value for the molar mass of O2 gas. Now, mercury oxide, mercury 2 is a 2 plus, oxygen is always a 2 minus, so that's the formula for that. And then, so we have 2 different elements here. So mercury's atomic mass is 200.59. So we're just simply going to add that to 1 oxygen, which is 15.99. For a total of 216.58 grams. Okay. Now, what is the balanced equation here? So what we have here is a decomposition reaction of mercury oxide. Is going to be heated, and that's what Joseph Priestley did. He heated it, and then it produced oxygen, and then also mercury. Mercury comes out as a liquid at room temperature. All right, now balancing that equation, we see we have 2 oxygens here and we only have 1 here. So if we put a 2 here, 2 here, and now we have a balanced equation. That'll help us get the mole ratio that we need to solve this problem. Okay, so we want to start with what's given here in the problem, which is 125 grams of O2. That's where we start. Now we need to do the molar mass ratio. So in 1 mole of O2, we've decided there is 31.98 grams of O2. And now we need the mole ratio of the O2 to the mercury oxide. Okay, so that's really what we're looking for. So we want mercury oxide over here on top. In our mole ratio here for O2 is 1 mole of O2 based on that value there. But there's 2 moles of the mercury oxide right here. So 2 moles of mercury oxide. Okay, I'm going to switch our just a little bit this way. All right, now, so what we want to do next is we want the mole ratio for the mercury oxide. So in 1 mole of mercury oxide, there is 216.58 grams. That comes from here. Okay, now we're ready to solve the problem. So again, notice that our units are going to cancel. Grams cancel of oxygen there. Moles of oxygen here cancel. Moles of mercury oxide cancel there. We multiply the numerators together, multiply the denominators together, do the division. And the solution then is 1,693.1 grams of mercury oxide. That's how it's done. Okay. So if you can master that skill on these mass problems, master the skill of dimensional analysis, make sure that you know how to do a balanced equation, determine the molar mass values, correctly write the chemical formulas that you're going to be asked to do, you're going to be walking in tall cotton here. So you're going to be doing very well. Okay. All right. Thank you for watching, and we'll talk to you later.